Hi dear students, let's see this question that came in KVPY 2020 SX Part 1 Physics paper. The question is from the topic of oscillations and this is a procedural way to do this question. So let's see how we will do this question. Although many students could not do this question in the exam, but this question has been asked previously in JEE mains as well. So let's see how do we do this question. The So basically this is a particle which is performing oscillations in the presence of this restoring force minus kx cube, where I think x is the x coordinate of the particle, k is some constant. So the time period of the oscillation is capital T and the amplitude is A. So we have to find what will be the time period when the amplitude will be made twice. Okay, so this is what we have to calculate. Now, how do we do this question? So basically we can say that force is nothing but minus kx cube, which can be written as mass into acceleration, and acceleration can be written as v dv by dx, since the acceleration is happening on will be happening on the one particular axis. Now if you integrate this equation minus kx cube dx and you integrate this, so you're going to get mv square by 2, okay, is equals to some constant. I'm performing indefinite integration, so some constant c minus k into x to the power 4 upon 4, correct? So I have written one constant of integration c over here, right? Now basically let's find the value of c, okay, in terms of amplitude. Now if you realize, suppose particle is oscillating like this, okay, particle is oscillating like this, so this is the mean position and this is the equals to amplitude. So when the particle will be at its amplitude, then its speed will be 0, of course, right? So putting v equals to 0 and x equals to a in this equation, you will get 0 is equals to c minus k into a to the power 4 upon 4. That means c is equals to k into a to the power 4 by 4. So we will put this back over here and we are going to get mv square upon 2 will be is equals to k by 4, you can take common, and this will be a to the power 4 minus x to the power 4. This is what we get, right? Now this will give us v is equals to, you can take 2 by m on the right side, so this will become k upon 2m into a to the power 4 minus x to the power 4, and whole thing will be inside under root. This is the value of the speed, right? This is the value of the speed. Now let us basically write the speed as dx by dt, okay. So if you write speed as dx by dt under root of k by 2m into a to the power 4 minus x to the power 4, so this will become dx upon, this whole thing was in the under root, a to the power 4 minus x to the power 4 is equals to under root of k by 2m into dt. This is what we get, right? Now very easily we can do, like in one or two more lines we will be able to solve this question, okay. So now think, for the particle oscillation, let's say particle was here at t equals to 0, okay. Let's assume that particle was here at t equals to 0. Of course we can assume this without any loss of generality, because origin of time, origin of x coordinate, origin of y coordinate, origin of z coordinate, all these things we are free to decide, and there is no loss of generality when we choose any particular instance as t equals to 0. So let's say that particle was here at t equals to 0, right? So we are sure that particle will reach here at capital T by 4, correct? Because if the particle was here at t equals to 0, then particle will reach at its positive extreme at t by 4. Okay, we also assume that particle was moving in this direction. So basically particle will reach here at t by 4, then it will return and it will complete its oscillation in capital T time. Okay, so let's say particle was here at t equals to 0, okay, and this limit uh, was 0. Again, particle was here at capital T by 4, okay, and this will be x equals to a, right? Now let's integrate this. So I'm not actually going to integrate it. I'll just tell you a very smart technique, okay. Just let's put x square is equals to uh, a square sine theta, okay, because of the obvious reasons, because we will be able to you when you get this type of thing, then this will make this a perfect square. So now what do we get from here? This will be 2x dx is equals to a square cos theta, d theta, right? Accordingly, the limits will change. So if x is 0, then theta will be 0. If x is equals to a, then a square will get cancelled and theta will be equals to pi by 2. Value of dx can be found out from this. So dx will be a square cos theta d theta upon 2x. A square cos theta d theta upon 2x. Okay, 2x. X again can be written from this equation. X is a root sine theta. A under root sine theta. Correct? And this thing is left. So this will become a to the power 4 minus a to the power 4 sine square theta. So which will become a square. 1 minus sine square theta is cos square theta. So this will become cos theta. Right? And on the right hand side we will have under root of k by 2m into capital T by 4. This is what we get. Right? Now the question is over, because if you see on the LHS what we are getting, this a square and a square will get cancelled. 1 by a will come outside. Okay, now remaining thing, if you see, it's an integration in theta with the limit from 0 to pi by 2. Okay, that means it's a definite integration from 0 to pi by 2. So if it's a definite integration from 0 to pi by 2, that means it will be a pure number. ठीक है, इसको इंटीग्रेट करके जो भी वैल्यू आएगी उसमें जब अपन लिमिट्स डालेंगे 0 से पाई बाय 2, so we are going to get a pure number. Okay, cos theta and cos theta will anyway get cancelled, but we are not required to integrate that. You need to understand कि हमें ये इंटीग्रेट करने की जरूरत ही नहीं है. You just need to understand that कि ये एक प्योर नंबर बनने वाला है. So for the time being, let's call that number as lambda. ठीक है, ये जो भी है मैंने 1 by a I have taken outside and remaining thing I am calling as lambda. ठीक है, is equals to यहाँ से ये basically k upon 2m into t by 4. So from here you can see that a into t is constant. Amplitude into time period is constant because everything else is constant, right? So I think you've understood the essence. A into t constant aa gaya, right? Now question is done. So if you double the amplitude, time period will become half. Okay. If then like answer will be t by 2 because we are doubling the amplitude, so time period would have become half. Very, very obvious. So option B will be the correct answer for this question. I hope you would have enjoyed this solution. I hope you would have understood everything perfectly. So without integration, basically we have done this. That's it. Thank you.